Acknowledgement. I'd like to acknowledge that we are on the traditional, ancestral, and unceded territories of the Musqueam people. It's particularly germane to this presentation because so much of what happens with forests in India is tied in with the indigenous people of that land. Let me first introduce our speaker today, Professor Sumeet Gulati, who is in the Food and Resource Economics program.
Yeah.
Oh, you can't hear me? Oops. Seems the button's on. The light's on.
Yeah. Yeah, the battery died, so
The battery's died, so we'll have to just yell here.
Zoom is okay,
Zoom is okay.
but you have to.
Sumeet is a professor in the Food and Resource Economics program in Land and Food Systems. He has worked on a variety of questions in environmental economics, started his career looking at the relationship between trade and environment, then done some fantastic work on various aspects of climate policy, the economics of, for example, the salience of gasoline taxes in BC, as well as some work on carbon credits. And more recently, though, he's switched to something that's dear to his own heart. Sumeet is a wildlife enthusiast, goes bird watching all the time. And he shifted his focus to looking at wildlife conservation and the economics of wildlife conservation. His lab is called the Wildlife Conservation and Economics Lab in LFS. And he's got some great papers recently, a paper that looked, for example, at what COVID lockdowns did to the prevalence of bird populations in India. You know, as more lockdown, birds started to come out, people began to see them on bird apps. He's analyzed the sort of economic value or risks from various wildlife and conflicts, and also done some interesting work looking at how people living close to forests think about forests. So without much ado, I'm going to hand it over to Sumeet to talk about his work on elephants. Thanks.
Okay, I'm supposed to stay here. Thank you for having me present here. Thank you for the invitation. And thanks for that introduction, Milind. It's true, I've been sort of switching around doing different things as I have moved through my career. This is my latest avatar, I think, and hopefully my last one, but you never know, right? But this is now focusing on human-wildlife conflict mostly, but yeah, issues around conservation. And just, I think the tools I use here are very similar to the tools I used when I was studying carbon policy. So it's not that big a jump. It's just, I need to understand a lot more. So I'm learning a lot more here and around conservation. So just Milind talked about our lab. Our lab's this really nice place with some of our representatives here already. And a lot of this work is frankly just my lab doing it, right? This is Sarah's master's thesis. Sarah's right here. If you can just say hi to them. Okay. And Sarah and then Fernanda and Sasha were WorkLearn students who helped with the data. And some of the figures you'll see here are Sarah's, and some of them are Sasha's and Fernanda's. And then there's people who have been involved in this research. Sanchaya is at WWF India. Nitin Sekar is also at WWF India. They were responsible for the fatalities database that we will be using in this paper. Rahil started using the infrastructure forest clearing database, and he introduced Sarah and I to that. And so we have a slightly different version than what he had, but he is the one who sort of started looking at this data. So he is, I think, an important player in this paper as well. And Rahil's a PhD student at our lab as well. Okay, so just to sort of to talk about the elephant. Most of you guys know this is the Asian elephant that we're talking about here, and we're talking about conflict with the Asian elephant. Has, from what I've learned, has very complex matriarchal, has a matriarchal structure, but has complex emotions and behaviors that most humans like me previously thought was only unique to us, but actually is not. It's it's visible that they grieve and respect places of death and seem to have behavioral issues from trauma. The Asian elephant is also classified as endangered. 60% of its population lives in India. We're going to talk about forest clearing as well for infrastructure. India is growing, has a renewed drive since 2014 to improve and increase its infrastructure in India. And this involves like linear transportation, power lines, irrigation, some nonlinear, like dams and mines, etc. We're going to sort of just let me give a little more context to this. And I think why we should care about infrastructure and its impact on wildlife is in 2014, then the prime ministerial candidate Narendra Modi said, you know, this environmental clearance is a roadblock to growth. And he promised that when he'd come into power, that he'd ease this environmental clearance process. And so since then, post-election, based on what Rahil has actually looked at, the stage of stage one, the approval of stage one and stage two forest clearance applications has gone up by 60%. What the primary reasons, actually three of them, one of them is it's been digitized, so the process moves through quicker that way. But other than that, it's made it easier for complying with the Forest Rights Act. And the thresholds for a ministerial review at the Indian federal government have gone up significantly. So previously, projects larger than 0.15 square kilometers, it's 15 hectares, were reviewed by the Ministry of the federal ministry. Now you need to be above 40 hectares or 0.4 square kilometers before you need central involvement. So it's just a lot of this decision making has now been localized, which has allowed this review process to move quicker. Okay, so what are we going to ask here is relate this human this clearing to human wildlife conflict, and human elephant conflict in particular being the most costly form. It seems the most obviously costly form. It's not actually, I think, but is amongst the most salient, most what people think about, and the costly forms of wildlife conflict in India. It's been estimated it kills about 500 humans every year, and about 150 to 200 elephants die from human elephant conflict every year. And it's argued that it's increasing over time. And there's several papers that seem to say that habitat destruction or degradation is the reason why this is increasing over time. So we're going to use a database that comes from this image. Why this image is here is because newspaper articles or media articles will talk about someone being involved in human-elephant conflict. So this one is from a state called Odisha, and this is this is from July last year, where elephant kills a woman in this village called Sambalpur. Okay, in Sambalpur district, not in the village called Sambalpur. Sorry. And so we will ask then, does forest clearing for infrastructure development have a causal impact on fatal human-elephant conflict, or the killing of humans or of elephants? That's the singular question in this paper. And I said why we should care, because there's a lot more forest clearing now being approved by the federal government, by the central government in India. And from what we know, the central government or even the local forest office doesn't consider the impact of forest clearing on human-elephant conflict. They will consider other things like, what is the loss of forest, the forest itself. They'll talk about habitat reduction and its impact of that on the environmental services that come from the forest, but they will not measure the wildlife conflict that comes from it. So we hope to add to sort of the cost, how people view costs of there being forest clearance on their decision to determine whether, to decide whether they should have more clearance or not. Okay, so that's why we should care. I want to talk quickly about the database. I know I'll run out of time fast if I keep going at this pace. So this is coming from media reports, and there's an organization called Save the Elephants in Africa, which starting 2004 did a sort of a uniform Google search for elephant articles talking about elephants. And then they collected this database with all these articles. They sort of made sure they didn't look at articles which weren't meaningful, but as long as they were about elephants, they put it in a database. The people who are part of the project here, Sanchaya and Nitin, led the conversion of this database into a text database of all these articles into a Excel sheet, which said, where did someone die? How many people died? And also what kind of conflict occurred, right? So they had a whole bunch of other information in there, but WWF India read each article, manually coded the conflict information into an Excel sheet, which we have access to. And then our lab, led by Sarah and Fernanda and Sasha, have done a whole lot more processing of this database to look for errors, but also clean up some things that were not about wild elephants, etc. Okay, so we are focusing on conflicts with wild elephants. There are 227 districts out of approximately 600 some in India that reported human-elephant conflict, and they come from 23 states. Okay, so one of the things that the database helps us see is where are the elephants, okay? And so this is a separate mini project, and I'm just presenting something from there. But this is the IUCN range. The dark blue there is the IUCN range for elephants, for the Asian elephant. The lighter blue is the districts that have any part of the IUCN range in them. So we just sort of filled out the districts there. If we looked at the human-elephant conflict database that comes from media reports, this is where we see conflict. The interesting thing is that we see conflict in areas that is not recognized as IUCN district. And so I think it's an interesting thing that you could use and we hope to have something that will be more automated, but potentially media reporting of charismatic species like elephants, which is often reported by the media, and especially if it's fatal conflict, is often reported by the media, could be a source to see where elephants are, while IUCN ranges may not be updated as readily as something like that would be. So this is sort of one thing that's coming out of this project. The other one is that we are focusing on fatalities. And so we have isolated these reports on fatalities alone. And based on this media database, you can see over time from 2004 to 2018 till we have this data, fatalities have been rising quite significantly. The reported fatalities around 200 a year towards the end of our time horizon. That's the government, like I said, estimates 500. So not all of them are obviously captured in the English media database here. This is not looking at other non-English media sources. So just in the English media database, about 200 out of those 500 seem to be captured towards the end of our. Okay, so just to clarify what is called human death or injury, it includes things like direct confrontation with the elephants, incidents resulting from elephants destroying huts or other living structures. Elephant death and injuries include intentional and unintentional shooting, poisoning, electrocution, and incidents caused by trains and other forms of transportation. So just to sort of tell you, once we look at fatalities, where do these fatalities actually occur? A lot of them occur in central India. That's where the darkest, you can see the darkest section there. That state that is the darkest there is Odisha. And that's where a lot of our fatalities occur, especially recently. Then you see some fatalities up in the south and then in the northeast. I think there's 1 or 2 fatalities in the north that you see there, but it's very light, as you can see. Okay, when does death occur? There is a seasonality to it. Okay, there seems to be this dip around March. There seems to be a dip around September, October. But then there's sort of these cycles that human-elephant conflict seems to be higher in sort of towards November, December, and sort of in the winter months, and then there's a peak around July, June and July. Okay. So where do we get our deforestation database from? This is what Rahil started his work on, and he got this database from the Government of India's Ministry of Environment, Forest and Climate Change. This is a part of that whole digitization process. So they give you data from before 2014, which is why we have data from 2004 to 2018, but 2014 is where the official digitization happened, and is downloaded from the ministry's Parivesh proposal. It lists the date the proposal was submitted, the stage of approval the project is in, the area of the forest that is proposed for clearance, the purpose of the project, and the districts in which the project is implemented. So we will use the square kilometerage of forest approved for clearance in a district for every year. I mean, actually every quarter, it says every year, but actually we use it every quarter because you know which month it was submitted, which month the approval was granted. So you'll see this is what you see, that black line there is deforestation by year in this graph, but it's deforestation approved that year. And up there is the 5-year moving average for deforestation over the last 5 years. I've put 5 years here because we're still not sure about what to use as the appropriate measure for causing a human-elephant conflict. But we sort of had settled on 5 years. We're not sure about that anymore. But so I have 5 years here. And we'll talk about that in a bit. Okay, so just this is not from this. What you see here is within elephant districts. So within elephant districts, there seems to be an average around 35 to 40 square kilometers every year. That's approved for deforestation, and with a 5-year moving average around 150. That's by all districts, all the elephant districts, which are 200 and something, right? But if you looked at each project, so Rahil looked at each project as well, and he had all the projects over India. We only focused on elephant districts. So this is from Rahil's paper, and it talks about the number of projects. So there were from 2015 to 2020, just to give you an idea of what this looks like, there were 8,329 projects with a mean size of around little less than 0.15 square kilometers, 14.59 hectares, and the total area deforested was 121,552 hectares. Just want to point out one of the things that is clear too is looking at a smaller time frame. I forget what the time frame is. Actually, I had it written here. I forgot exactly. So deforestation for building roads, mines, and etc. accounts for about 17% of yearly forest loss. So someone estimated how much yearly forest loss is happening. Through Rahil's database, we can say how much of it was approved for forest deforestation. For infrastructure deforestation is about 17% of the yearly forest loss. Okay, so that's sort of to give you context of the database. There's other databases that we use. One is the EVI, the Enhanced Vegetation Index. We have access to elephant population data by district. It's not a panel, so we haven't used it yet because we have fixed effects and they capture that anyway. But we do account for growth through a proxy called nighttime lights. We account for population density. We may use human footprint index, but we have that. We haven't used that yet. But, so this is some of the other data that we put together that we might end up using. Okay, so some visual correlations, just to sort of tell you that that a lot of fatalities seem to be concentrated in the East Central, like you saw when I showed you that graph. There's quite a few fatalities in the Northeastern and Southern, not so many in the northern parts of India. Deforestation by region over time, just visually, you can see in the East Central region, there seems to be a whole lot more. The average of deforesting for infrastructure is also significantly higher than the other districts. Okay, now just within Odisha, do you remember that one state that was really dark? That was this state of Odisha. Within Odisha, the interesting thing is if you drew the cumulative number of human deaths and you plotted the cumulative kilometer square approved for deforestation and elephant deaths, they track really well together. They seem to be moving quite sort of the correlation seems high. Okay. And then we also sort of said, okay, let's look within districts within Odisha. So now this is like saying, let's look within Odisha. What happens here on the left here with that red coloring and the hatching is the hatch indicates districts with a higher than average total death count. The coloring, the darkness of the coloring indicates how many people died in that district. I think it's all the way from 2004 to 2018, or it's just 2018, sorry. Yeah, it's just 2018. No, wait, sorry. I'm saying this wrong. Right, so the one on the left talks about deforestation in protected areas. The one on the right talks about human people, the human death in the districts of Odisha. And on the left, the hatch indicates if you have higher than average total death count. So you can see the hatch and the colors have sort of a correlation going on there, where you feel that wherever there's more deforestation, there seems to be more death. Okay, so this is just some visual correlations, trying to get a sense of where the database is pointing us without having to run a formal regression. So then for Sarah's master's, we're doing this formal estimation, trying to estimate what is the causal impact of deforestation on human death. And we will regress human and elephant fatalities per district on square kilometers of approvals of forest clearance per district. We know there's a few problems, but let's think about what the identifying variation is. The important thing to recognize is if forest clearance for infrastructure development within the district is not determined by district level conflict, we can estimate this. But in order for it to be not determined by district level conflict, we need to not have some confounders which might be determining both of them together. We need to not have the government looking at conflict and saying, oh, there's a lot of conflict there, let me not do any more deforestation, right? So I think those assumptions is what then we try and make sure we have it sort of valid, given the kind of data we have and the kind of confounders that we account for in our regression. And some of those confounders we think we can account for through capturing coverage, increased coverage, because that may be determined as over time, as infrastructure is going up, coverage of human conflict may also be going up. And we want to make sure we capture that. It might be that districts that have a lot of growth, have a lot of economic growth are where infrastructure is put in. And then economic growth brings more people into conflict with elephants. So that might be causal. So those are sort of confounders we need to be careful about. And we want to make sure that our regression strategy captures that. Okay, so I'm going to skip over this. I don't know how much time I have left. So. Yeah, 10 minutes, right? So I'm going to skip over this here and this as well. Let's have a quick look at our results. This is where sort of we are still in the phase of trying to figure this out. Now, this is OLS regressions, which I, again, have issues, so we'll talk about that. But OLS regressions, the thing is, it's not clear as to how much, when should deforestation impact human-elephant conflict? Is it just contemporaneous deforestation, which is that the first row right there, deforestation that quarter, or is it overall deforestation in the database that we see, which is cumulative, or is it that in the last 3 years, in the last 5 years, etc. Right? It's not obvious to us. And talking to people who are elephant experts, including those people who helped us set up the database, it's not very clear to them either, right? Some people say this is a 30-year problem. Some people say this is a more immediate problem because elephants adjust. It's not clear. So we've got a whole bunch of options built into our regressions, and we haven't been able to choose which one is the right one yet. So what matters? Current approvals or past approvals? Then also there's clearly heterogeneity by type of deforestation. Is it linear? Is it mining? Is it something else, right? Is it for electricity? This sort of, we can come up with coefficients that differ based on the type of project that is approved and the type of deforestation that is approved. So we're still sort of figuring out which one and how to put that out for it to be meaningful in a way it should be. The other problem is that we have count data. We have data on deaths, human and elephant deaths, and there are lots of zeros in our database. Right? There are lots of districts, when we have it organized by quarter, there are lots of quarters where a district did not see any human or elephant death. And when you have that, sorry, just going back here, it's quite clear that OLS, even though if you had, it's supposed to be consistent, which means if you had lots of data points, you'll get the right unbiased coefficient. It won't be in this case because of the over dispersion, the fact that there's just lots of zeros in here. And so in that case, a negative binomial or a Poisson regression is recommended to be what you need to do instead. And in fact, it seems negative binomial is the one that's most preferred, given the amount of dispersion that we have in our over dispersion we have in our database. So we also ran a negative binomial specification. This sort of phase sort of felt like 5 years, maybe the last 5 years, the moving average of last 5 years matters. And we have coefficients here for human and elephant death. We have, some of this is just to sort of see which fixed effects work and which ones don't. We can ignore that for now. But we have sort of a significant impact of human fatalities from deforestation from the previous 5 years. Just to sort of clarify, this one says the log odds go up by about 3%. The log odds of a human fatality in that district, in that quarter, goes up by 3% for every additional square kilometer approved for deforestation over the last 5 years. Okay, so this also is very hard to sort of put a number on, so we can do some conservative plots. The OLS coefficients are much smaller, so that's our conservative plot. That one's saying about 24, is that right, Sarah? About 24 deaths over the last 14 years can be attributed to the deforestation approved. Okay, out of the whatever the number, the overall number we have, and we can sort of put it out by which area, which region. So you can look here. This is the number of fatalities. It's going up to almost 1, but it's 0.8. But our coefficients are putting about, this is the number of fatalities we can put for each region by year based on our coefficient. Slightly less conservative plots, when you use the negative binomial, the coefficients are larger. There we have about 85 to 90 fatalities, human fatalities, attributed to forest clearing, approval for forest clearing. Okay, so there too we've got this separated by central, and you can see central is largest because of the fact that there's a lot of clearing. And so a large amount of clearing means more deaths attributed to forest clearing in the center of India. Anyway, so human fatalities alone, just I forget, but it's about 85 to 90 human fatalities over the last 14 years we can attribute to the government approving forest clearing for infrastructure. So just, I think, want to just end by saying, why is this important? I think it's sort of a formal analysis. It does a few things. It does a formal analysis of this media database and gives us some insights using another way of sort of getting citizen science, rather than someone having to go out and measure this and going to the government and getting data on human-elephant conflict. It's also, I think, a first formal analysis of the relationship between government-approved deforestation and human-elephant conflict. Identifies this cost of deforestation, typically unrecognized in environmental evaluation. And hopefully this is a large and culturally diverse region that gives us insights on what might be happening externally other than just the area that we're looking at. Few caveats. One thing to remember, our coefficient is on approval. Clearly, it's not exact deforestation. It's what the government approved to deforest. And it's likely that what people actually deforest after approval is bigger. So in that way, we are getting a bigger coefficient on approvals than what is actually coming true from deforestation itself, because we have undermeasured approvals. Undermeasured deforestation. Additional limitations, we don't know the time span of deforestation that affects elephant behavior. We also know elephants move across districts. We have restricted our analysis to a district level, but there may be cross-district effects, which we haven't accounted for. Okay, I think that's it, right? Yeah, that's it. So Sarah's here too. She'll take all your questions. Yeah.
Data set and investigation. I'm wondering, you mentioned that there are possibly a number of different confounding factors that might limit you from actually figuring out whether station is the factor that they think. One of them you mentioned that I think is that you're already going to do this the median coverage.
Right.
The other couple of areas that you've already looked at are population growth in all the different regions, human population growth.
Exactly.
And also locate either directly or an estimate of elephant population size. The elephant population size, I assume, is probably decreasing, so that you'd imagine that that would lead to a decrease in frequency of human elephant population, and human population is probably increasing. And it just seems like there's so many confounding factors, it's kind of hard to result from, right? So I'm wondering how you're thinking about that.
Sarah, you want to take that? Although I should repeat it, maybe. Is that how it is? Or
Yes.
right. So sorry, the question is whether we have accounted for all the confounders, and obviously some of them are human population growth, the other ones being elephant population growth, and then media coverage. And I think we have thought about these and all of them, and I'll just bring it over to Sarah, who will will tell you how she's dealing.
Oh God. Hello. Okay. So most of the confounders you mentioned, we are controlling for. We include a control for change in population density. We also control for nighttime lights, which is usually a good measure of change in economic development broadly in the region, which then we also assume tells us something about kind of human activity in the districts that we're looking at. The biggest challenge has been controlling for elephant population because we don't have time series data for that anywhere. I have started working on that. I think it's in the slide somewhere. We have forest division. So the challenge that we have is that we don't have district level population for elephants, and we also don't have time series information. And so the district level elephant population I've been able to get by taking elephant population data that we have at the forest division level and then translating that to district level populations, which was very faffy and I don't think is necessarily very reliable. But then on top of that, it's not it's not time series. And so we don't really control for that, but we do have also district level fixed effects. And then we also include quarter state year or state quarter year fixed effects, which should capture changes at the state level over time, if that makes sense. And so maybe we could make some sort of an argument that that might capture changes in elephant population at the state level, but it's a little bit of a tenuous one. But that is a limitation that we have, is that there's just not much credible data on where the elephants are, which is also why we're excited about the media database, because it tells us something about that. But yeah, it also shows how much of a data deficiency there is there.
Yeah.
Really interesting. I always have two questions. I was just curious about how you your results with the media database. How much,
Right.
just curious how much.
So the question is how would this number change if we had more coverage from non-English media, right? And I mean, it's a complete speculation, and I think your guess is as good as ours, but I think we would think we'd get more coverage, so we'd be able to cover, instead of just 200, hopefully we'd get a higher number. If there are truly 500 people dying every year, hopefully we'll get the number up a little bit, which ideally should give us some more variation. I don't think it should matter for the coefficients, because the infrastructure development, I mean, it could make a difference in the size of the coefficient because the number of fatalities might be higher per district. We'll capture more every year or every quarter. But I mean, it's noise at this point, right? And at this point, if it's, as long as it's noise and it's not, something that we particularly, we can at least say something about. We should be okay with the causal effect coming out of that so far. Yeah.
Yeah. So I'm curious, are these like raw
These are raw counts for that. Yeah, the question is if these are raw counts for that in these maps, yes.
symbolizing districts rather than or each district has a different number of people and then one
That's a good point. So the question is about normalizing. Do you want to answer that, or should I just go ahead? Okay, so I mean, we have thought about normalizing. It's partly why we also have population numbers in there on the right hand side to control for that. And the interesting thing is Odisha has fewer elephants. If you look at the numbers, it has fewer elephants and fewer people, but it combines for most of the deaths. Most of the elephants are here and in the northeast, in the south and in the northeast. There are not so many elephants in central India. So it's true, if I normalized it, I mean, if we normalize this, it would be a little bit different in terms of these graphs, right? You'd see per population density, you have more people dying. Per elephant, you're seeing more people dying in central India. I think we don't have that issue with the estimation because we have population numbers on the right-hand side already. So the question is whether the narrative in the media articles has some sort of blame built into them. I haven't read enough to give you a good answer for that. Sarah, do you have an answer for that?
Yeah, so our database has almost, I think, 2,000 articles just for India. And there's not so much blame. They're actually surprisingly very, very neutral, to the point where a lot of the articles are just very short and read more like bulletins almost, where it says, in this village, X people died due to an interaction with a roaming elephant. This is the X fatality in the last 2 months in this area. Human elephant conflict is on the rise, kind of, but it's generally quite objective. But again, it's hard to say because there is probably so much that we haven't read, but our team members at WWF India have actually manually read every single article. But I think they would generally agree that there's not so much, but it would be really interesting to do some sort of sentiment analysis based on the articles that we have now.
Actually, I don't know who's first and who's second.
I'm just gonna basic students question.
Sure. Sure.
So the first question is from Walter. He's asking, is there a time lag between deforestation approval and actual deforestation? And how is it controlled for India?
Okay, so the question, I don't think I have to repeat that one, do I? All right. So the question here is the time lag between deforestation approval and not. And I think Rahil, who used this database first, tested for that. And he found that approvals typically meant that deforestation occurred. He actually looked at deforestation data, checked approval data, and then found that there was not much of a lag. It seems like once people get into this first layer, we're talking about everyone who has stage 1 approval. Stage 1 is either the local forest officer or the Forest Advisory Council of the Ministry of Environment and Forest has approved this for you're not supposed to be deforesting till you've actually paid into I forget the name of the fund, but it's the CAMPA, right? You're supposed to have paid into CAMPA and then you can start deforesting. But for Rahil found that almost everybody at stage 1 has started or is close to having done all the deforestation. Okay, so there were a bunch of people, but let's go with you first. Yeah. Yeah. So yeah, the ecological processes is the question. We've thought about a few, not all of those. And Sarah has been thinking about this. Sarah, you want to talk about this? She's looking carefully at
Yeah.
the harvesting, especially.
Yeah, so we started with our data at an kind of aggregated at the annual level. Can you hear me okay? Yeah. But we wanted to account for some of those ecological processes that you mentioned. So we've reorganized our data at the quarterly level so that we can actually capture some of those seasonal effects. And we're actually in the process of reorganizing those quarters so that rather than being the calendar year quarters, they're actually more aligned with the seasonal cropping patterns. And some initial regressions are showing that there is an effect of cropping likely. And then we're also including the enhanced vegetation index to look at the effect or the availability of natural forage for elephants and how that might impact fatalities. So that's kind of how much thinking we've done. But then, no, but that's a really interesting thing that we haven't considered. Yeah.
Just want to say that all our recent meetings with the WWF team in India and us is pretty much focusing on issues like that as to, you know, what is the seasonality and are we capturing it appropriately. So, but yeah, we're working on it.
So important to be making these integers, like, and human impact and also impact to wildlife. And wondering if you could maybe think about again about the like ethical implications of making these integers, because once these things are truly, you know, people dying, deforesting, it becomes kind of a value judgment about what are we going to do about it. And I feel two pathways. One is no longer being valuable enough to do the development. The other pathway is no longer valuable enough to have elephants or maybe to have people. And I'm just wondering how you think about that and maybe how.
I'm going to just repeat the question. It's about the value of making this link and actually establishing a causal link and the ethics of establishing such a causal link, I guess. I have a certain view, and I'm sure, Sarah, you have a certain view. So maybe we should have both of us say what we feel here. I mean, my thought here was that that here is something that is not, it's sort of mired in uncertainty, and it's important to make it so. Right? And then my thought was this is about getting people to recognize there are these costs from deforestation, which they could have ignored before because it was uncertain, right? And it was not clear. So I think if we can establish that, at least somewhat convincingly, we force people to pay attention to that. But there are potential other issues where people might find solutions, like you said, which is no more elephants here or no more people here. I mean, that's not what I was thinking about. I was hoping just to inform the discussion. But Sarah, do you have anything else?
Ooh. I feel a bit put on the spot. So I don't think I'll have a very eloquent answer to that. I mean, it's very obviously something we're constantly thinking about, and it's work that is ultimately rooted in care for people and elephants and kind of those ethical considerations. And then it's also a really political issue, right? Because a lot of the deforestation is happening in places where maybe minority ethnic groups don't have much of a say about how forests are used and forests that they used to have access to, and they no longer have access to, and things like that. So all of those questions are kind of running in the back of our minds. And even though, yeah, we're just running kind of these regressions, when we actually get to writing the paper, that is the kind of stuff that we want to be writing about and thinking about. I do kind of agree with you ultimately that being able to show with some kind of certainty that cutting down forests for these, it's not just any deforestation, right? It's deforestation with very specific goals, development goals, large scale infrastructure goals. Like, how are those projects serving the populations and the animals and the forests that people depend on? I think those are really important questions. So I'm hoping that showing that there is an effect and how large that effect can be, even with our most conservative estimates, I'm hoping that the ethical implications of that will be positive. But I think that's a really, good question that I'll probably lie awake thinking about tonight.
Okay, I'm gonna try to bundle up. There's a couple of questions by Justin and Juan Diego chat. We're try to bundle up a little bit. It's about elephant behavior and how has it been considered, like when usually fatality events or like with females with offspring or males being female. And mostly elephants are complex animals and how intensive. How has also the role and related to resource assets and how you.
So I think so the question is a pertinent one. The original database, when it was coded by WWF India, was focusing on things like, is it a male or a female elephant? Is it a female elephant with offspring or not? We just didn't have enough data points to actually use that. So that is lost in this regression here, but they tried to collect that data. And like Sarah said, a lot of these articles are really short. They don't give you enough information. So there wasn't enough data points to be able to do some of that. So that's where that went away. And the other part of the question was something to do with, I forgot. We're out of time. Okay. Okay. Yeah. Okay. Thank you, everyone. Yeah. Sounds good.